During this presentation, we have to study the concept of conservation of energy of a system of particles. Suppose the system consists of n number of particles, then the work done in moving the system from position 1 to 2 is given by the equation W12 equal to summation I equal to 1 to n integral Fi dot dRi, limit varying from 1 to 2. You know the value of Fi. Fi equal to dpi by dt, which is equal to mi into dvi by dt. This is the velocity of the ith particle. We have to use small v. Then the value of vi equal to dri by dt. From this we can write the value of dri, which is equal to vi into dt. So instead of Fi, we have to substitute mi into dvi by dt. Instead of dri, we have to substitute va into dt. Now W12, which is equal to summation I equal to 1 to n integral vi dvi, limit varying from 1 to 2 into mi. Here mi is a constant, mass of the ith particle, we have taken it out. Then vi dvi. See here, instead of Fi we have to substitute mi dvi by dt. Instead of dri we have to substitute va into dt. dt get cancelled. Mi vi dvi. We have taken out mi outside. V dv is v square by 2. Therefore, this is modified as summation over I equal to 1 to n mi vi square by 2, then lower limit 1, upper limit 2. W12, which is equal to I equal to 1 to n 1 by 2 mi vi square 2 minus half mi vi square 1. This is our T2, this is our T1. Therefore we can write W12, which is equal to T2 minus T1. So this is equation A. Now in this equation, replace the value of Fi by means of negative gradient of Vi. Here we have to replace Fi by means of minus grade I into capital Vi. Here capital V is our potential, small v is our velocity, capital V is our potential. Then this is equal to minus of I dou Vi by dou xi plus J dou Vi by dou yi plus K dou Vi by dou zi. This is the value of minus grade I Vi. Gradient operator in general is I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So minus grad I Vi is this much. You know the position vector R. R equal to I into X plus J into Y plus K into Z. Then dr equal to I into dx plus J into dy plus K into dz. This is the value of dr. Whereas dri equal to I dxi plus J dyi plus K dzi. If you take the value of fi dot dri, fi dot dri, which is equal to, take the dot product between these two, minus I dou vi by dou xi plus J into dou vi by dou ii plus K into dou vi by dou zi dot I into dxi plus J into dyi plus K into dzi. Now you have to take the dot product. I dot I 1, J dot J 1, K dot K 1. All other things are vanished. So this is equal to minus dou vi by dou xi into dxi plus dou vi by dou ii into dyi plus dou vi by dou zi into dzi. This is equal to minus dvi. So instead of this term fi dot del ri, we have to substitute minus dvi. Now W12, which is equal to summation I equal to 1 to n integral minus d capital Vi. Here V is our potential. Limit varying from 1 to 2. This is equal to summation integral of dvi is with a negative sign is minus Vi. Here if you use the summation I equal to 1 to n, you may get minus V for the entire system. Minus V. Limit varying from 1 to 2. This is equal to minus of V2 minus V1. If you use the minus sign, minus V2 plus V1. So the value of W12 from this condition is V1 minus V2. See this? From this condition, minus V2 plus V1. So from this we can write W12 equal to V1 minus V2. Say this is equation B. Now we may go to the conclusion part. From the equations A and B, it is obvious that T2 minus T1 equal to V1 minus V2. You may write T2 minus T1, which is equal to V1 minus V2. Then we can write T2 plus V2, which is equal to T1 plus V1 equal to constant. If the applied force is conservative, the total energy of a system of particles remains constant. This is the conclusion we have arrived. If the applied force is conservative, then the total energy of the system of particles is conserved.